32. Okay. Today we will be covering about enumerations and autoboxing. In morning session we will cover enumerations and autoboxing, and in the evening session we will explore more about annotations. Okay. Since I did not want both the topics to be covered in one session because both are very important. Okay. That is enumerations and annotations, because annotations are used everywhere. That is why I just wanted both of them to be separated. I did not want to take a single session for both of them. Okay. So next, last class we had our last sessions, couple of sessions we had exception handling. So let us start with the enumerations. Okay. So what are enumerations? So enumerations are nothing but, give me a second. Please give a couple of minutes. Okay, so enumerations are nothing but a list of, they are a list of named constants. Okay, they are list of named constants. We know how to define a named constant, right? We know how to define a named constant. Can anyone tell me how we can define a named constant? Or did we ever discuss about named constants in previous classes, or at least constants? Can anyone tell me? Hope all of you are able to see my screen and hear me. That's what I assumed, and I just started. Can you all listen to me or hear to me? Okay, okay. Yeah, you are able to see my screen, right? Okay, yeah. So values, constants are nothing but you cannot change the values. That is correct. But did we discuss about how to create named constants? Yes. So what do you mean by final, Kavita? Yeah, how can we create a final constant? Yeah, Kavita, right, yeah.
Yeah, I mean, you use final public static final, and you write, if you want to make it a constant, they use the word, I mean, in the capital form, and they write.
Yeah, correct. Yeah, correct. But it is not static always. So we can create, yeah, we can create constants by using final keyword, right? We can create constants using final keyword. Okay, so whenever you are defining any instance variable which you want as a constant, you can create it using your final keyword, which makes a particular variable as constant, and you have to declare that constant within, like while you are declaring itself, you have to initialize it, right? So that is how you create a constant. For example, say I have, this is not working. Give me a second. Can you please bear with me for a couple of minutes? Please give me a couple of. I'll just pause I'll just pause sharing. Okay, so I'll resume again. Okay, give me a couple of minutes. Yeah, thanks. This pen was not working. I just installed the software again. Okay. Yeah. Let's continue. So we were like so when to create a constant we use final, and say for example if you want to create a string with some value, right? Final then is equal to some value. Okay, so str. Okay, so value of str you cannot change. Okay, that is how you create final variables. Here str becomes your string named constant. Can everyone am I audible? Sorry, yeah. Can everyone see the screen? Okay, can everyone hear, or am I audible? Am I audible? Okay, yeah, thanks. Thanks, Kavita. Yeah. Sorry, I was not sharing my screen. That's why you were not able to see the screen. So it usually happens in between whenever this happens. Okay. Yeah. So this is the str is called as your named constant. Similarly, we can create named constant using enumeration, but this is not just one single named constant. Okay, like we created here. It is a list of named constants. Okay, it is a list of named constants, and they are alternative to your final variables. Okay, so final variables, that is what we saw here, right? An example of how to create a single named constant. Okay, what happens in other languages? For example, in C++, this is just a reference. Okay, this is just a reference. Like whenever you create an enumeration, or whenever you say an enumeration, right? They are just a list of named integer constants. Okay, they are just named integer constants. For example, we create a constant like a final int whatever it is. Okay, say I is equal to 10. Okay, wherever you want to use 10, you can use I. Okay, similarly, the only thing that is allowed, only type that is allowed, at least in C++, that is integer. Okay, you can use only integer constants for named constants. Okay, but in Java, they define what we know what are class types, right? We know what are class types. So they define class types. Okay, that means they define a data type itself. Okay, enumerations define data type itself. So whenever we discuss about data type, what does come to your mind immediately? Immediately, what does come to your mind? Yeah, what does come to your mind whenever we say data type or type? We can create variables of that particular data type, right? We can create, yeah, correct, string, integer, or data types. Yeah, that is what is the advantage of creating a data type. Whenever you are creating a data type, you can create a variable of that particular data type so that you can store some values and you can use those things for processing, that which is nothing but your data, right? So this defines, enumeration defines what is called as class type. We know what is a class type, right? Similar to what a class can have, an enumeration can also have constructors, methods, instance variables also. Okay, since this defines a class type, we can have constructors, methods, and instance variables also. Okay, there are some restrictions with respect to enumerations when compared to classes. We will see those things in few minutes. Okay, so how do we define our syntax for defining a enumeration? Okay, so we use what is called as enum keyword. Okay, that is what we have used here. Okay, so we use the keyword enum. This is our access type as usual. We know there are 4 different types of access types: public, private, protected, and default one. And this is the name of your enumeration or enumeration type. Enumeration type. In C++, you can have only integer constants. Okay, but here you can define anything. This is user-defined enumeration. Okay, this is user-defined enumeration. So what is the syntax? Access type enum and identifier. Okay, and open and close parenthesis. Okay, so whatever you define inside, they are called enumeration constants. These are enumeration constants. These are enumeration constants as mentioned here. Okay, these are all enumeration constants. So months, I defined a enumeration data type. Okay, this is our type. Okay, these are all our enumeration constants. So note that each type is separated by comma, and the finally we will end it with semicolon. Okay, finally we end it with semicolon. Okay, there are 1, 2, 3, 4, 12 constants. Okay, these are all called as constants. Okay, Jan, Feb, March, April, May, June, all are called as enumeration constants. Enumeration constants. Okay, so how do you access and how do you process enumeration constants? Let's see. Okay, so each enumeration constant is simply what is an each enumeration constant? It is simply a public static number of enum. Okay, it's a public static number, public static and final number. That is very important. Okay, public static and final. So when you make it as a public static and final, what does that mean? Any constant, any variable, instance variable, when you make it as a public static final, what does that become? It becomes global variable. Okay, and the value you cannot change it because we have static and final. We cannot change the value. You have to initialize while declaring itself, and it is public. You can access it globally. Okay, it becomes a global variable, global shared variable or shared variable. Okay, and each enumeration. Okay, this we have declared an enumeration right here. We have declared an enumeration here, and these are all constants. The type of each constant is this one. The type of enumeration type itself. Okay, and the type of each constant. The data type of each constant is enumeration type itself. Okay, we will see why that is the type of each enumeration constant is enumeration type itself. There is two different things, right? Here we have enumeration type and enumeration constants. Okay, enumeration constants are members of enumeration type. Okay, the data type of enumeration constant is the enumeration type itself. Okay, data type of enumeration constant is enumeration type itself. Okay, we will see why these are the data type of enumeration constants are enumeration type itself. One way of thinking this is like we have declared all these things, all these constants within this enumeration type. That is one way of thinking. Okay, but we will try to understand why that is the data type of each enumeration constant is enumeration type itself. Okay. So as we discussed, each enumeration constant defines each enumeration defines data type, right? So what can we do with data type? We can create variables of enumeration type. Okay, we can create variables of enumeration type. That is, I have created, right? That is the data type I created, and then I can create a variable of type months by name. Say for example, month. Okay, I can create a variable of type month, which is nothing but our enum type. We create enum type using keyword enum. Okay, this defines data type. Okay, even though this defines a data type, while creating a variable, we will not use new keyword for instantiating objects. Okay. So this is like similar to how we create a variable for any primitive data type, right? So in any primitive data type, how do we create? Just say int I. is equal to 10. I'm initialized and declaring and initializing this to one particular value. Okay, but in case of objects, what we do? Okay, so here we are creating object references. Okay, object references, but in this case we are just creating variables. That is why we always call these things as variables only. Enumeration variables, we call them as variables, not objects. Even though enumeration defines a class type. Okay, even though it defines a class type, we call them as variables instead of instance variables or not instance variables, object references. We just call them as variables only. Okay, that is why we do not use new keyword for creating these variables. Okay, we will not use new to create objects. We are just creating variables. We are just creating variables. They are not object references. They are just variables. Okay, and how do we create a variable? As we know, with respect to our primitive data types, just data type and identifier. Okay, data type and identifier. This is the enumeration data type, and this is your identifier. So, for example, as I mentioned, okay, this is a variable of type enumeration type months. Okay, so we will see what are the things that we can achieve with these things with the enumeration. So when I create a variable of type, when I create a variable of a particular enumeration type, the values that we can assign to that variable will be the constants that you define within a particular enumeration. Okay, that is months. Okay, month. Okay, so here we have defined months, right? Here we have defined months. So what are the constants that we have defined here? Jan to December, right? So this is a variable. So remember, this is a variable. Okay, but these are constants. Okay, so the only values that we can assign to this month variable are these values, the constants that we have defined. Only okay, the only variables that we can, the only values, okay, only values that we can assign to this particular variable of type months is what are the constants that you have defined within the enumeration type. Within the enumeration type. Okay, so for example, if I create an int I, okay, if I create a variable of type int, what are the values that I can assign it to this int variable? We have a range, right? Whatever the range it may be. Okay, within that only we can assign the values to this I. Okay, but again, if you exceed that value, it will get converted into respective data type, and then you'll get the result. Similarly, enumeration type, you define a list of constants, and whenever you create a variable of that enumeration type, whatever the range or whatever the list of constants that you have defined within the enumeration type, only those things you can assign it to these enumeration variables. Okay, enumeration variables. Okay, so what are the values that we can assign it to? Month. What are the values? Here we can assign only one value. Okay, what are the values? From Jan to December we can assign. Okay, from Jan to December we can assign any value, any constant to this particular variable. Okay, so how do we do that? We have to do that using this is, say for example, this is enum identifier, that is our month. Okay, and how do we do that? Enum type, that is dot constant. Anything you want to, if you want to put as January. Okay, January. So how did what allowed us to use this particular enumeration type? We are directly accessing it, right? Can anyone think of why we are accessing enumeration type dot constant? Can anyone think and tell me? No, Kavita. It is a list, correct? It is a list. But what allows you to access through the data type? This one, what is that? You are accessing. Say, for example, I have assigned this value, right? Month dot January. Okay. Yes, correct here. Yeah. So we have told, right, while discussing, each constant is what? Each constant is what? Public. Okay. They are not only public, they are static. Okay. They are not only static, they are final. Okay. Since it is public, it is accessible to everyone. Since it is static, we can directly access from the name of the type itself. Right? I hope all of you have understood whatever the static thing that we discussed before. Okay, they define class types or class members. Right? They define class members. Static, they define class members. So how can you access any static member? Class name dot member, right? Can you now associate this with this one? So now this makes sense, right? Now this makes sense, right? So month dot January, like this is how you access the constant and assign it to a particular variable of enumeration type. Say for example, I have some other this one. What is that? Enumeration. Okay. Can you assign this? This is of type month, and can you assign mobile dot Samsung, something like that, or Samsung something, whatever you want to define. Okay. Samsung dot some mobile. Can I assign it to this? No. For integer, you can only assign integers, right? Then, but that again, if you assign some other thing, that will get converted into something else, and then you'll see the result, right? So that is how the data type of the variable should be the data type of the constant that you are assigning. Okay, this is, as you can see, this is similar to accessing like the class type itself, static class types. Okay, so how can we use relational operators? These are all constants, right? So that is why, since these are all constants, what we can do, we can check for their equality using equal to operator. Okay, someone has a question. Yeah, Pawan, go ahead.
Yeah, I actually just want to know, it's like in that while declaring enum dot constant, okay, do we need to use only those where enum constants which are defined before, or we can use something else?
This you are talking, right? So
Yeah,
we have
right.
defined, yeah, so here we have defined
Yeah, right,
public,
right. Yeah, my
enum and
doubt
null.
is, my doubt is if let us say December is not defined, okay, just for our assumption, okay, what happens if we tell enum dot December?
Yeah, that will give your compile time error. It will not show. It will not. You will get the compile time error itself. Okay. So that means the only things, the rule is defined like this only. Only things that you can assign, only values or only constants that you can assign to a particular variable of an enum type, right? Variable of an enum type are the constants that you have defined within that particular enum type.
Okay.
Okay. For example, that is what I was mentioning, right? For example, for int I is equal to, I have defined one variable int I. Okay. Can you assign any value to this integer? We cannot assign. There is a specific range, right? Yeah. Within the range only we have to assign. Even if you exceed the range, that will get converted back to some other value, negative or whatever the value. We have seen one of the example, right? We tried to convert it. We tried to exceed the value, but that again we got some other result, right? Based on how it is defined. Okay. So we cannot assign any other value to I apart from the range that you have specified. Similarly, what is the range that you are specifying here? The range is or the values, the valid values that you can assign to a particular enumeration type are these only. Only these values that you can assign to a variable of enumeration type. Okay. That is very important. If you try to assign some other value, that will result in compile time error. Okay. You will not be able to do it. But anyway, we will be most of the time we will be using IDE, right? Most of the time by default, most of us will be using the Eclipse only. Other people might use NetBeans or some other tool which is provided by Oracle or some other people. Okay, but most of the time by default we will be using Eclipse. So Eclipse will automatically tell you. It will not allow you to assign the value itself. Okay. But if you try to use some other editor and try to assign it, definitely when you are trying to compile, you will come to know that it's not a valid value.
Okay.
Okay. Yeah. So that is the values that we can assign to an enumeration variable is the values that we have defined within an enumeration type or constants. Constants that are defined within an enum type. Okay. Since these are all constants, we can use relational operator equal to check for their equality. Check for their equality. Okay, we can define, we can use equality operator to check for their equality. Okay, we'll see all these things with an example. Okay, let me finish some of the things and then we will go back to the example and then we will understand. Okay, so since these are all constants, okay, since these are all constants, we can use these constants within a control switch to control switch statement. Okay, we know how we can use and some expression you give switch expression, and then you with case statement you compare the value of this expression with the case constant. This is case constant. This whole thing is your case statement, right? This case constant is compared with the expression here, whatever the expression that you specify here. Okay, this expression controls your switch statements. Okay, case statements with case constants. Okay, similar to that one, we can use enumeration types with your switch to control the switch statement. Okay, we will see an example of those things. Okay, so within while okay, let us take an example and then we will understand exactly. So why I wanted that was within case switch and case statement. Here we are accessing the constant using enum type dot constant, right? Okay, enum type dot constant. That is your enum type dot constant. Okay, since constant is of type enum type, we have to access it through enum type dot constant because it is public and static. Okay, but within switch statement, you have some expression, say for example, some expression is there, or you enter one enumeration list itself, enumeration type, okay? It takes enum type E, okay, and case statements, you have mentioned case Jan up to case December, okay, case December, you have specified up to case December. So one of the value that you specify here, that will be compared with this case, and then corresponding statements will be executed. But while defining case constants, okay, you have case statements, right? Case, and you specify case constant here. Case constant here, right? And then colon, and then you know the syntax for case. So this is your case constant, okay? While defining your case constant, you don't use the enumeration type, okay? You don't use the enumeration type that you use here, like to assign a value to an enumeration variable. We used, how did we access it? We accessed it using enumeration type dot constant, okay? But within switch statement, for case constants, we will not try to access the values with this syntax, enumeration type. We just access the constant, okay? We just access the constants in the sense, like say for example, if I want to write a switch statement, forget about this expression, okay, here also et enumeration type dot some variable, okay, x, okay, and then you have constants, case Jan up to case December, okay. Here I cannot access it using et dot Jan or months dot Jan, okay. This will result, trying to do this will result in an compile time error, okay. This will be a compile time error because this constant we access it just by naming Jan, Feb, and all those things, okay. For any constant, right, for using 10 also within your program, you can't just use it as 10. You have to declare and assign it to some variable and then use it, right? Okay. So similar to that one, here you can just by, say for example, yeah, you can use it in expression, but that is what, if you want to tell that one particular value is an int, this can be an int, float, or whatever it is, okay. If you want to tell that this is an int, you have to mention it as int I is equal to 10 and assign it to that one, right? Similar to that one, here, who defines the type of this constant? The expression that we have specified in our switch statement, right? Here, that itself defines the type of the constants that you are going to define within the case statement. That is why we will not specify the enumeration type within the case statements, case constants, okay? Looks like, yeah, looks like, Pawan, you still have a question? Pawan, do you still have a question? Okay, yeah, he doesn't have a question. Okay, yeah, Kavita, correct. Whatever you told is correct. I was trying to explain why we use only January, okay? So that is the reason, because whatever you specify in the switch expression, that defines or that determines the type of the variable or the constant that we use for case statements, okay? That is what I have mentioned here. The case constants, okay? Case constants are nothing but the constants that we specify for case statements, okay? While defining case statements, constants should not be prefixed with your enum type, okay? So let us see an example that will make things understand easier, okay? So here I have defined enumeration constants. Since they are all public static final, by default, okay, by default, they are, as we discussed, public static and final, okay, similar to are instance variables or variables that we define inside our interfaces. Okay, interfaces we have already defined. Okay, or we have already covered in our previous session. So these are all by implicitly, these are all public, static, and final. Okay, public, static, and final. Okay, so let us see what are these things. Okay. So here we have defined the month enumeration type. Okay, it need not be whatever the constants that you specify within the enumeration type, right? It need not have to be like capital letters. You can just follow the naming conventions. Okay. So here, what did I do? I just created a variable of type current month. Okay. So here, as we discussed, the only allowed values are that are defined within the month, that are defined within the month enumeration. Okay. So how can you assign a value enumeration type dot value? In slide I have mentioned like January, February as the first letter as uppercase, but in code I have mentioned everything in uppercase. Okay, that's how I have defined or declared the particular enumeration. That's why I'm using like this. And then how can we print the value? We can print the value just like that. Can anyone tell me how this value will be printed? How this value will get printed? Is it like months dot December or just December? Can anyone take a guess? Yes, correct. Yeah, Pawan is telling December. Yeah, correct. She is also telling December. Correct. So there is a, we all know that there is a method, right? ToString method. We all know that there is a ToString method. So this is overridden to display just the value constant, just to display the constant of a particular variable that we are trying to print it. Okay, ToString method. ToString method is overridden to just display the constant, not the whole thing. Okay. Okay. Here we have one example. So we have defined one more string variable here. Okay, string object. Okay, and then season. Based on our condition, we assign or we decide which is the season we are in right now. Okay, which is the season we are in right now. So and then we will try to print it. Okay, but here we are using if statement. Okay, and so we are trying to compare. See here, we are using equality operator. Okay, we are trying to compare the value within current month to this month, and this month, and all the same logic goes here. Okay, and then assign the respective season. Okay, based on the month. Okay, so note that while accessing also, we access it using the enumeration type and the constant. Access it using enumeration type and the constant. Okay. So we print out the value, whatever the season we are in right now, based on the current month. Okay. So I have assigned December as current month, and let us see what exactly it prints out. Okay. Okay. So forget about these things. We'll just concentrate on non-highlighted stuff. Okay. So current month is December. We have assigned December to you can see that one here. Okay, so you can see the current month what I have assigned is December. Okay, I'm trying to print that one here, so I just printed December. Okay, and then we are trying to assign season based on the month, and then we are trying to print the season. Current season is winter. Okay, current season is winter. So based on the month we have decided and then printed the season. Okay, similarly, how can we do the same thing using switch statement? Here's a piece of code. So here we pass the variable current month. Okay, we know the enumeration type of the enumeration type of current month. We know the enumeration type of current month. That is why the constants, these are all case constants, okay, that we have defined. This is what is meant by case constant. Okay, these are all case constants. Okay, based on the variable that you have passed here, the type of the variable that you have passed here, the types of these constants are derived. Okay, based on the expression or the variable that you pass here, the type of the constants are derived. That is why we don't mention et dot ec within switch statement. Okay, within switch statement. So let us try to do some few things here. Okay. Okay. So first one is Pawan's question. That is, can we assign any other variable? So any other constant. Okay, is equal to month start. So whatever the values that we have defined, right? Only those values we are able to see here. Okay, that is what is the functionality of your Eclipse. So as soon as you type dot and enter, or you just have to just type dot, it will show you all these things. Okay, and let me try to define. Okay, it will not allow. It is showing error, compile time error. Okay, January cannot be resolved or is not a field. Numbers are also, constants are also called as field. Okay, so this is not a field. January cannot be resolved because this is not a field. So only values that we can assign to a variable of particular data enumeration type is the values that we have defined. Okay, otherwise it will result in compile time error. And let us try to access one of the constant with months. Okay, here also you can see the error. Okay, the qualified, whatever it say, what it is saying is the qualified case label. Okay, the case constant, they have mentioned it as case label. The constant case constant or case label months dot December must be replaced with unqualified enum constant December. Okay, so it should not be qualified, it should be unqualified constant. Okay, enum case label should be unqualified enum constant. Okay, that's what we discussed just now. So here that is what I meant by saying like it results in compile time error. Okay, it results in compile time error. Let's move on to the next slide. So there are a couple of methods that is predefined within your enumeration. Okay, what are the enumerations that you create? For example, values and value of. Okay, here when you try like this, say for example, try to create or assign a value to enumeration. Okay, months. Okay, I am not sure whether all of you will be able to see this one. We can see these two methods: value of, values, value of and values. Okay, also enumeration type, we will see this is related to what is known as the generics. So that's why I don't want to discuss about that now, but these two things we will concentrate on: value of and values. Here value of takes a string and values it returns enumeration type array. Okay, so Pawan has a question. Yeah, Pawan, go ahead, Pawan. What is the advantage of using enum? Okay, can anyone think of why should we use enumerations? What is the advantage of using enumeration? Can anyone think of that one and tell me? I think we have discussed this one when we were discussing about interface constants, I guess, if I'm not wrong. Yes, correct. It is. It defines a new data type. But what is the advantage of using? Yes, correct. Tina is telling defining in one place. Okay. Mohammed Ali is telling when we only want fixed values. Yes, exactly, Mohammed. Atif. Yeah, that is also true, and the Tina is also true. So yes, we cannot. Yeah, constants we are defining as constants only, right? So we cannot change it. Correct, Karika. So there are so many things associated, right? So main advantage would be like we define few constants so that we specify. There are many advantages, right? So we specify certain range. Say for example, in months. Okay, you can define one enumeration within months. Okay. Say for example, I have say let me okay, let me create one method. Okay. Okay. So what I will do, I will do these things only, whatever I have done here. Okay. Okay. So I will tell you the exact meaning. Just give me. Let me think of this one. Okay. So okay. Let me take only one. Okay. I'm just trying to print January. Okay. Yeah, Pawan has an interesting question. Yeah, let me finish this, Pawan. I will come to your question. Okay. Good that you're asking some interesting questions. Okay, let me finish this one. Okay, let me finish this explanation. This is your question. This is the answer to your question. Okay, I am trying to explain it to you. Why we normally use, what are the things that enumeration addresses? Okay, so we have one test method which takes a string. Okay, so what are we doing? Which takes on one particular string. So what are we doing here? We are trying to compare this with January. Okay, and then we are printing. If it is January, we will print this one. Similar to that one, we can say February, March, April, May, whatever it is. Okay. So while calling this, what can I do? While calling, let me make this also a static. Okay. Test method. Okay. So this is one way. Okay. I'm just calling this. Where is the? Why is it showing error? Okay. I'm just passing. Nothing happens here. Okay. Nothing happens here because I don't have anything defined here, right? I don't have anything. I can pass whatever I want here. Okay. I can pass whatever I want here. Okay. So assume that I have so many things. Okay. This is just one simple example I am telling. Okay. So in usually for 5, 6, 7, 8, 9, 10, 12. Okay. This is just one simple example. Okay. This is one simple example. So what are the values that we need to specify here are only Jan to December, right? Not more than something else. I don't want anything else to be defined here. Okay. If it has something else comes, I'll just mention. Please observe whatever I am doing. Okay. These are all very useful. Say for example, what I'm telling is my utils, right? I've just defined one particular class where I'm that I will be using it as for my utilities. It is like my utilities. Okay, wherever I want to use it. Okay, so dummy month. Okay, assume that you have some business rules set based on some business rules. Business rules is nothing but some if else conditions based on your business requirements. Okay, you have set some business rules, and say for example, if the month is month equals some other, you assign some value here. If month is equal to January, assign some values. Say is equal to some 10. Okay, some you just assign 0 and then assign it. I is equal to 1. Okay, and then similarly 2, and then this will be 12. Okay, based on that one. Okay, so assume you have something like if I is equal to 12, that is December, you do so many things. Okay, if I is equal to 12, you do so many things, whatever you want. Okay, business rules are set here. Okay, and here by default, okay, this condition is not at all required actually. Okay, but you have to handle that situation, right? Say for example, this one, what is that? Sorry. If I pass some dummy in a month, okay, if I pass some dummy month, that also should be handled. We should get at least some logs saying like, okay, this is not a valid month. Okay, this is not a valid month. Are you all able to hear me and see my screen? Okay, yeah. Yeah, that's right. Some business rules you have set, some business rules. Okay, so I can here what I can do here. I can do whatever I want. I can pass any string here. Okay, I can pass any string here. But what like here, what are the things that we need? Only 12 things we need, right? 12 months. In a year, there are only 12 months. I cannot pass anything other than 12 months. Say for example, like this one. Okay, so this might result. This is assume that this whole thing is a big application, and you might have written some exceptions, all those things based on your conditions. Say business might be using it. Business is nothing but the end user or who is aware of a business, what exactly he does. Okay, the business might be using, and he will think, okay, there is one text box. You can just enter whatever you want. Okay, you can just enter whatever you want. So I am using that particular application. I will enter ABCD, knowing that okay, I can enter anything. But you want to restrict only to specific values. Okay, in such cases, what you can do, you can define one enumeration like this. Okay, months, and then create. Okay, create another method. Okay, and then what will happen if I try to call this with whatever I have defined here, not this one. Okay, okay, so you cannot pass anything other than whatever the values that are defined in your month. Okay, you have to pass only this is a valid condition. Okay, whatever the values in a year, you can have only 12 months. So in such scenarios, instead of using strings, right? Instead of using strings, it is better to use enumerations. Also, if you want to use strings, there will be other issues also. Say for example, somebody might have written like this. By mistake, I would have written, okay, month AUGUST. But whatever, if I want to call this and pass it as thinking that, okay, this is a, I mean, when we are reading it as a valid month only, right? August, right? But here the condition fails because we are character by character we are checking it. Okay, so let us see that one as well. So it will say invalid month, dummy month. Say it is saying dummy month because August is compared with A caps and U caps. That is both are August and A and U are in uppercase letter, but I am passing only one uppercase letter. So that is considered as dummy month because none of the if conditions passed. So it came to here and it printed dummy month, right? While comparing, I'm just giving you some simple scenario where you can use this current this enumeration. In such scenarios, you have assume that you have a list of constants, specified list of constants. Okay, for example, if you want to have, say for example, you are writing some test cases. Okay, JUnit test cases or whatever it is. Okay, so you want to say like is the results. Okay, I want pass and fail. There will be some other conditions. Okay, pass and fail. Only these two things should be there. If a particular test case passes, I'll say pass. If a test case is if a test case fails, I'll say fail. Okay. Say for example, you're testing some particular functionality. If it passes, you may mention it as pass, or if it fails, you mention it as fail, or you can mention any other things also. Okay. So in such scenarios, right, you want to restrict the result only to some specified values. Okay, like we have specified here. Okay, we don't want in first place itself we don't want to have any invalid values to be entered. Okay, any invalid value to be entered here like this. Okay, this will be like while comparing, right, if somebody makes mistake like this, such mistakes, it will be difficult to kind of like find out. Okay, we'll be thinking, okay, we have written code in a taking everything into the consideration. Okay, but when we pass this, it will fail. So that whatever the business rule that you have written here, that will not at all get executed. Okay, but what we will be thinking, it has to get executed because I gave valid value to that. Okay, so such things will be there. So in order to avoid those kinds of errors, we can define an enumeration, and you can create such methods. Okay, without passing, right, before passing a value to a method, that will be checked whether you have respective, I mean, whether you have a right value within this particular method or not. Right, that is how we use enumerations. And Pawan is hope. Pawan, did you get your answer? So what are the explanation for your first question? Did it make sense? Did you understand whatever I tried to explain? Okay. And second question is, can we create enum int so that we can change the range of int? Okay, Pawan is asking one more interesting question. So can we create enum int like this? Okay. Can we create enum int? Can you all see? Type name is not valid. Okay. Type name int is not a valid identifier because I'm not sure whether I have mentioned this. Probably I would have mentioned it. Whatever the word that we say as keyword, okay, Java keyword, whatever the words that we use as Java keyword, okay, for example, okay, give me a second. Okay, so just observe the keywords here, okay, the color of keyword. So this is also a keyword. Okay, this is also a keyword. This is also a keyword. So all these things are keywords. These are all so here. This is also a keyword. Enum is also a keyword. Okay. So whatever we specify as keyword, we cannot use it as identifier. like this. Okay. So, can you see this? This is also int is also an identifier. Okay. Whatever you type, that is a data type, but still you can see the difference, right? The color. So whatever this is also displayed in same color. Okay, this also defines a particular data type. This is also used internally by Java. Okay, those things we cannot use it as identifier in for anything for that matter. Okay, not only for enumeration. Okay, so for that matter, you cannot change the range of the primitive data type. You cannot touch at all. Okay, other things you might consider, but whatever the things that you like primitive data types and the keywords and all those things, right? All those things you cannot touch. You cannot use them as the keywords at all. Okay, so that is why you cannot change the range by defining an enumeration of type int. Okay, got it, Pawan? But that's a good question. So you should think that way. Can we create? Yeah, you should try to create it. So I had asked a couple of questions last time for you also, all of you to try and explain in today's class, in next class, that is in today's class. Okay, I don't know whether we have tried those things and came with some came with answers. Okay, so the two important methods are values and value of method. Okay, they are predefined methods within your enumerations, whatever the enumerations that you create. Okay, the moment you say enum some name identifier, okay, these two methods will be there in your that particular enum data type that you create. Okay, the signature is like this: value. It returns an array of enum type. Okay, returns your constant enumeration constants. Okay, and this value of this takes a string which represents should represent a constant. Should represent a constant. Okay, so let us see that simple example. So how you can use those things. Okay, we are so the simple examples for seeing how you can use values and value of, right? Yeah, you can see here. That is, so months dot values. Okay, so it gives an array of all the constants. Okay, when you try to print that, it will show all the months within that particular month enumeration type. Okay, and then if you want to print the value, if you just want to get the value of a particular string, say for example you have some string JANUARY, and if you want whether the particular constant exists in a particular enumeration type, you can check that also. So you can just pass the string and check whether the value exists or the constant exists within that particular enumeration type. Okay. Let us execute this. Let us comment these two things. So this is what we try to print using our print statement. After we got the constants using values method, by using values method. Okay, by using values method. This is using value of method by passing December as parameter. Okay, So we have assigned December here to particular string. So we have assigned December and try to get the constant from your month. And here we got all the constants here and trying to print it. Note that we are using new form of for loop. Okay. Okay, let's move on. So you understood till now, you understood, right? Yeah, Kavita has a question. Yeah, Kavita. Yeah, go ahead, Kavita.
Yeah, when we write enum class, we have written only January, February. I mean, we have just written the list of constants or enum. I mean, if I write like instance variable or methods in enum, how should I access those one?
Yeah, we will see all those things. Today we are discussing about enumerations, right? Let us discuss one by one. Okay, we are just trying to understand the basics. Okay, so one by one. So we have those things here. Okay?
Oh, we
We
have
have all
that.
those things.
Okay.
We have all those things. Okay.
Yeah, yeah.
So we will discuss all those things. Okay.
Okay.
So that is what. So enumeration, we know enumeration defines a class type. By now we all understood. I have told around 10 to 15 times by now, I guess. Enumeration defines a class type. Enumeration defines a class type. So there is a reason for repeating the same thing again and again. Okay. That is like when we repeat the same thing again and again. If I tell one time, if it doesn't stick in your mind or in my mind also, it will stick. Second time when I tell, it will stick. If it doesn't stick after the second time, third time when I tell, it will stick. Okay, that's why I keep repeating the same thing so that we will try to understand the exact meaning. Okay, so enumeration defines a class type. It again defines a class type. What does that mean? It defines a class type. We cannot use, even though it defines a class type, we cannot use new operator for creating while creating the variables of enumeration type. Okay, so because enumeration, we call it as variables, not objects. Okay, they are not instantiated like normal Java objects, but they have same capabilities that you have with other Java objects. Okay, say for example, you have your methods declared, instance variables declared. Okay, all these things you have defined in your methods in your class. Okay, similarly, you can have constructors also in class. Similarly, they have same capabilities. You can define constructors, you can define methods, you can define instance variables and all in one enumeration, and you can access all of them. Okay, we will see how they can be done. Okay, let's go. So that is what we were discussing, right? They can have instance variables, they can have methods, they can they can have constructors. Also, they can implement interfaces. Okay, they can implement interfaces. I'm not sure whether any other capabilities are provided in 8.7 or 8 for these enumerations. Okay, I'm not aware of that one, so I'll check and let you know. Okay, so as of now, whatever I know, like these things can be done. We can try to implement interfaces also. Okay, we can try to implement interfaces also. Okay, so one more important thing to understand about constants, enumeration constants is very important thing to understand is each enumeration constant is an object. Okay, that is why whenever I tell I refer this as variable. Okay, I refer this as variable, but enumeration constant itself is an object. Enumeration constant itself is an object. Okay, of enumeration type. So here we have within our months. Okay, so this is a enumeration constant. This is one enumeration constant. So this is our enumeration constant. This is an object itself. Okay, of January is an object of type month. January is an object of type month. Okay, January is an object of type month. So enumeration constant is an object itself of type enumeration type, in which we have declared them. We have defined or declared them. Okay, this is very important point to remember. Okay, so what happens when an object is created? What happens when an object is created? Say for example, you have A. Okay, so when an object of A is created, what happens? Can anyone tell me what happens when an object of A is created? This is a constructor. Assume that there is a print line here. Okay, okay, so I create A is equal to new A. So what happens when an object is created? Can anyone tell me? Simple question. It may be silly question, but these are related to whatever we are discussing now. Okay, object. So whenever we create an object of A, constructor is called, right? This is yes, correct. So yeah, that is Kavita is telling it creates it won't create a memory. It allocates memory for the particular object. Okay, it allocates memory. New is the operator which allocates new. Sorry, new is the operator which allocates memory. Yeah, correct, Kavita. Probably you might have written it in wrong way. So I didn't mean to ask that way, but when you create an object here in this particular context, constructor is called, and we will be able to see this particular message. Right. So what are we doing? We are creating an object. Constructor is called, and this particular message is displayed. Okay. Similarly, since each constant, enumeration constant, is an object, if you have a constructor defined in an enumeration type, if you have a constructor defined in an enumeration type, that will be called for each variable, or for a variable. It will be called for each variable that you create. Okay. So say for example, you have months. Okay, you have defined months. Okay, and then you have defined some constants: January, February, March, and all. Okay, so when you try to create an object, or when you try to create a variable, okay, of type enumeration type, or when you try to access, right, that time all the objects will be created and the constructor will be called for each constant. The constructor will be called for each constant that you have within that particular enumeration type. Okay. So when you define an instance variable with your enumeration type, please interrupt me if you don't understand these concepts. Okay. If you don't understand anything, please raise your hand, and we'll try to address. Okay. Kavita and Pawan, they have. Okay. Pawan has a question. Yeah, Pawan. Do you have a question, Pawan? Okay. So let me know if you don't understand any concept here. Okay. So enumeration constant, we know it's an object. Each constant will have, since these each enumeration constant is an object, if you define instance variables or methods, okay, each object will have their own copy of instance variables and methods. Okay. Apart from whatever we have seen with classes, constructors can be overloaded, right, in classes. Similarly, we can overload constructors in enumerations as well. Okay, we can overload constructors in enumerations as well. But as I told you, there are a couple of restrictions with respect to enumerations. They are, you cannot inherit a class, any normal Java class. You cannot inherit any normal Java class. Okay, and enumerations cannot be a superclass of any Java class. These two are not allowed. Enumeration cannot be a superclass. Okay, by default, we will see. Okay, so we have here. Okay, next slide we will see. These are the very important things that we need to do. Anyway, if you try to do these things, Eclipse will clearly tell it's not allowed. Okay, that's a compile time error. Those things. Okay, you cannot inherit a class. You cannot enumeration, whatever you have defined, it cannot be a superclass of any class. Okay, so you cannot do like this. Say for example, class A. Okay, class A, not class A, month. Class A. You cannot do this, or A extends month. These two things are not allowed. It cannot be a superclass, or it cannot extend any Java class. Okay, it cannot extend any Java class. Those are the two restrictions. So any doubts till now? Anyone have any questions? Okay. So even though we tell like enumerations cannot extend or inherit, any class, it by implicitly it extends one Java class from lang package, java.lang package called enum. Here, enum is a Java class. Enum is a Java class. Okay, enum is a Java class, but it's a keyword. Okay, this is. There are so many methods associated with that enum class. So here you can see. Always, I'd always suggest you to refer to this online API reference. Okay, online API reference from Oracle. Earlier it was Sun, now it is Oracle. Okay, so this is for enum class. Okay, this is for enum class. That it extends the object. Okay, this is extended by any enum you create. User defined enums extend this class. Not explicitly, that is the support is provided internally by Java itself. Okay, so there are various methods. We will discuss a couple of them here. Okay, we will discuss these things. These are related to your generics. Okay, these are related to your generics. That's an interesting topic. Okay, so these will address some other things that were kind of like happening earlier before Java 5. Okay, so related to type of data itself. Okay, so that is these we will not discuss. These are related to generics. So a few methods like compare to and ordinal and toolstring we will discuss. Okay, value of we know. Okay, and then the other things we will discuss later in when we are discussing about built-in packages. Okay, built-in Java packages. Okay, so Okay, so to couple of important methods are ordinal and comparative. Okay, ordinal and comparative. What is the ordinal? It's just each we have defined all the months, right? We have defined all the months. Okay, so we know how an array index. We are familiar with array indexes, right? Similarly, each say for example, so each constant, right, that we have defined, or each object that we have defined. Okay, this is one object or constant. This is one object or constant. This is one object or constant. Okay, so the each will have its own position. That is what is called as ordinal of enumeration constant. Okay, so it starts with 0. Okay, the value, the ordinal of Jan is 0. So December is 12. December 12. Okay, okay, Hari, yeah, Hari, correct, Hari, it is 11. I was thinking somebody will raise that question, but everyone was, I think, I'm not sure whether everyone was actively listening. Okay, okay, so December is 11. Okay, so it starts with 0. The ordinal starts with the position number itself. Ordinal is nothing but position number. Okay, that is position number, not exactly the index. It is the position in which we have defined particular constant, enumeration constant. Okay, that is what is called as your ordinal. So it starts with 0. Okay, it starts with 0. It starts with 0, and to access a particular ordinal, we use ordinal method. So it returns an integer which gives you the ordinal of a particular enumeration constant. Ordinal of a particular enumeration constant. Okay. Since these are all integers, we can use the ordinal values of two enumeration constants can be compared using your comparative method. Okay. Also, it's an integer, right? We can use equal to operator also. Okay. Let us see an example. What's the difference of value of and ordinal? Okay. So Pawan is asking what is the difference between value of and ordinal. Okay. Let me go back to Eclipse. Okay. Here, all these things are your constants. All these things are your constants, right? When you call a method on the value of some string, say this one don't write so fast, so I'm writing it slowly. Okay. Value of December, it will return this value, December. Okay. These are all the values. Constants are nothing but your values. When you pass a string, you will get this particular constant. It will just print this particular constant. When you are trying to print, right, print line of month of December means it will print December. Okay, that's what we saw here, right? Okay, printed that month December. That's what is the value of your month. So here also, when I tried to get the values, months of values, it printed all these values, right? These are all your values. The constant names itself are your values. Okay, but ordinal means ordinal is nothing but position number, constant position number, enumeration constant position number. Okay, it starts with 0, 1, 2, 3 till 12. Okay, I think all are still in weekend mode. All are sleeping, I guess. Okay, this is 11. So ordinal is nothing but your position. Okay, ordinal method gives this number, whatever the number associated with this ordinal. Okay, say for example, I'll define the month dot January dot ordinal. Okay, that will give you the result 0. It returns 0. Ordinal of December returns 11. Okay, ordinal of whatever the constant. These are all public, right? You can directly access through this months, name of the enumeration, months dot January dot ordinal. Okay, we'll show you an example. I think it is here only. Values of, okay, it's here. Okay, so let us take this example. Okay, and explain all those things. Okay, compare to, ordinal, compare to, and other things are also there. Okay, few more things are there. Okay, so here in this example, what is there in this example is, let us take a full screen. Okay, so in this example with values, months with values. Okay, so don't get this values with the ordinals. Ordinals remain the same. Okay, ordinals remain the same. That is everything. Okay, so months with values. This is another enumeration constant that I have defined. Okay. No problem. No. Okay, I will explain it to you. Okay, give me a few minutes. Let me finish this. While explaining this particular topic, I will explain values and value of as well. Okay. So here, what I have done, this is a different enumeration. Enumeration with months with values. Okay, months with values. Months with values. This is a second enumeration. So here I have defined one instance variable. There are three things happening here. Okay, and I have defined one constructor. This is a default constructor. This is another constructor which takes an int value. Int parameter. Okay, constructor will be int parameter. These two are overloaded. Now we understand what is overloading, overriding, and all, right? So this is a method. Okay, this is a method. So just wanted to introduce all these things in an enumeration. That's what Kavita was asking, right? So this is an instance variable. These two are constructors which are overloaded, and this is a method. Okay, so you can create constants this way or this way. Okay. When you create a constant this way, it will call default constructor. Notice that we don't have a parenthesis involved. Okay. We know that all these things are objects. All these things are objects. Okay. We know that all these things are objects. You can create objects by passing parameters to constructor or without passing parameters to constructor, provided you have default constructor. Provided you have default constructor. Okay, provided you have default constructor, you can construct without passing any argument to constructor. So this is what is specified. This is what specifies your constructor. Okay, that is what specifies your constructor. So let us see what exactly is happening by taking one example here. Okay, so January, this is an object of type this. Okay, so when you say January 1, what exactly happens? It calls this constructor. Okay, we have instance variable month number. Okay, we are assigning that value to month number. Okay, we are assigning that value to month number. Do you guys want any break in between? Probably in another half an hour will be done. Okay, so let me know if you need any break. We can have 10 minutes break and then we can continue from here. I am okay to continue, but if you need any break, please let me know. We can take 5 to 10 minutes break and then we can reconvene. Okay. Okay. So let us continue. Nobody told anything, and Pawan told okay, he is fine with continuing. Okay. So okay. Yeah. So we are calling this constructor and passing this 1. So 1 is passed to value, and month number value is equal to 1. Okay. So how can we access that number? Get month number. Don't get confused with this number with your ordinal. Okay. Ordinal is different and month number is different. That is what we have defined. Okay. Similarly, when we were discussing about objects, enumeration objects, methods and instance variables, we told each object will have its own copy of its own instance variable, its own methods, its own constructors. Okay. So these are all objects. Okay. So whenever I create Jan with integer 1, so Jan's month number will be 1 because I am passing 1 to this particular constructor, and this will be this Jan is an object and this will have a copy of month number. Okay, this will have a copy of month number. To that month number I am assigning value 1. This is similar to what you do with your classes, right? Each class will have its own copy, or each object of a particular class will have its own copy of its instance variables. Okay, its own copy of its instance variables. Similar to that one, Jan will have its own copy of month number, which is assigned a value 1. Okay. Similarly, December will have value month number will be 11. Okay, month number will be 11, 12. Okay, still people are sleeping. So that is what we passed in this constructor. This is done. So we can get that number. Yeah, you can write. Yeah, Kavita, can it? Yeah. Okay, let us try to write. Okay. That is what you are doing with your constructor only, right? What to say? Oh, man, you cannot. You can only set. Okay, cool. Okay. So we cannot set. We can only pass through your constructor. Okay. I got. Yeah, I got. Yeah, Kavita knows. I think better than me. Kavita knows what are enumerations. That's why she is asking that question. Yeah, Kavita, good. Yeah, so we cannot set the values of instance variables. We can only get those values. Okay. So whatever we passed, we are assigning that through your constructor. Okay. There is an interesting thing here with respect to constructor. Find out and tell me. Okay. Find out and tell me which are the access specifiers that we can specify to this particular constructor that we give to a enumeration constructor. Anyone knows? They can tell now itself. Otherwise, find out and let me know in next class. Okay. So we have assigned this value, right? We have assigned this value. Each will have its own copy of your month number, and then when you ask month number, it will give the respective month number. Okay. So anyone has any questions regarding these things? Wonderful. Yeah. He is telling only a constructor can assign value to a final variable. Yeah. What is the okay? My question is, what are the valid access specifiers that you can assign, that you can give it to a constructor of a particular enumeration type? What are the valid access specifiers? So I haven't given any specifier here. What are the valid access specifiers that we can give and why? Okay, and why? Find out and let me know in next classes. Okay. So Kavita is Tina is telling public and private. Okay. Illegal modifier. Okay. So tell me why that is. Oh, sorry. Tell me, it is. We can try these things. Okay, we can try these things, but there should be a reason for that, right? So try these things and find out and let me know. Probably you might be knowing it. So if you know, let me know here. Otherwise, we can park it till next session. Okay. So find out try to find out and tell me in the evening session. Okay. So. Okay, so Hugh is telling, okay, let me unmute him. Yeah, Hugh. Yeah, over to you.
If the constructor is private, you cannot instantiate the class.
Correct. So is there anything else?
Only if it's public. Only if it's public, you can instantiate the class. If it's private, you can't. So if you don't want someone to instantiate the class, you make your constructor private.
Correct. So are you telling we can have private access specifiers to these constructors, or it is not allowed?
If you use private access specifier, no one would be able to instantiate the class.
Correct, exactly. So here, with respect to enumerations, can we use private here? That is the question. Can we use? I understood what you are trying to tell, but can we use private? With your definition, can we use private? I'm asking whether anyone else instantiates or anyone else uses this, but I'm asking, can we use private with this particular constructor?
Oh, you mean can we use private with enum?
Yeah, with constructor, enum constructor.
Well, so, if we use private there, wouldn't the same principle apply as
yeah, so sorry to interrupt you here, but what I'm so
but,
with respect to
if the thing, even if we use private, since enum we not instantiating enum by using the new keyword, it should be able to work.
Okay, so what about public? Are you able to see my screen?
I'm seeing only private permitted.
Okay, okay. So that is the question. Try find out which are all the access specifiers we can use for constructors of enumeration types. Okay, constructors of enumeration type. Okay, so we can say we can use public, we cannot use public, but I want reason also. Which are the valid access specifiers that we can use with the constructors of enumeration and why? Okay, that is the question. So this is the question. Valid valid access specifiers for enumeration type constructors and why. So which are all not invalid, you can give reasons to those things. Okay, so that is the question. Please try to find the answer and Hugh spell private and default. Yeah, Hugh. You can. Do you know why we use the private and default? If you know, let it be. We don't want to discuss that. Let others find out and answer that question. Okay. 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 So let us go, move forward. So this is the one which we are testing it. Okay. With values. So we have instance variables. We have we have one instance variable, we have one getter, and then we have overloaded your constructor. Okay, we have overloaded your constructor. So how can we use those things? Okay, so we have created one variable and assigned a value to that variable, and we are trying to print that variable here. Okay, we are trying to print that variable here. Okay, what should be printed here? January. Okay, that is your value. Okay, and then we assigned another variable here. Okay, and then we used values method. It returns it returns all the constants that are defined within your an array of values that are defined inside your enumeration. Okay, you can iterate through all the values and then print them. Okay, that is one thing. And then that is what I just made it look a little better. That's it. And then sorry. Okay, and then I'm using get month number. Okay, so get month number, and then ordinal. Ordinal is nothing but your position number. I will explain this thing in more detail now. Pawan wanted some more clarifications on that. Okay, we are using compare to method. Okay, and then some we are trying to compare two objects, two variables of month variable, this particular enumeration type. Okay, so what is happening here? So let us try to run this program, okay, and then we will see and try to analyze what exactly happens when you run this program. Okay, okay. So this is one interesting thing. Okay, let me do one thing. Comment out unwanted things and then run the program. Okay, so let me do one thing. Let me comment out from here. Here. We'll uncomment one by one. Okay, so let us see what is there with this one right now. Not here. Okay. Not there. Okay, we don't have any other prints. Only two prints are there. Okay, this one and this one. Okay, only two print line statements are there. Apart from that, we don't have any other print line statements. All I have commented it. Okay, let us try to run this program. So what just happened? So this is this one, this print line statement. This one is this print line statement. Okay, I have assigned a January to this variable and I'm printing this here. So it is printing January. Okay, this is February, printing it here, it shows February. Okay, so what about these things? So yeah, he is telling that's because every time you call an enum, the constructor is called. Okay, not exactly every time you call. So these we mentioned that these are all your objects. Okay, these are all your objects. Okay, these are all your objects. The moment you try to access any one of these objects, constructor is called for all these objects. Okay, for example, okay, let us try to comment everything. The only statement that I have in this particular class is this one. So what will happen now? Can anyone tell what will happen now? Okay, for that matter, let us try this one. So it has to be either you can use it in your print line statement, or you have to assign this particular value to some other variable, instance variable. That's why it is complaining. So forget about that. Just see. Yes, exactly, correct you. So what I'm trying to do, I'm not at all trying to do anything here. Okay. So with this statement, right? With this statement, let me clear this one. With this statement, okay, I'm trying to print this value. I'm trying to run this program. So as soon as you try to access this one, right, this particular January, it is calling it is calling constructor for each object. Okay, that is why we called these things as objects of type this months with values. Okay, so whenever you try to access the constant and try to assign, okay, just by accessing here, it is calling constructor. Okay, so let us try to print this one. So what will happen? So we have created one variable and assigned a particular value. Okay, but what happened? It was supposed to call one more time, right? It was supposed to call one more time. Here it called once. Okay, so let me try to print here. Okay, so this is the second print. Second print. This one is first print. Okay. So before the first print is called, I mean after the first print, before the first print is called, all the constructors are called and objects are created, right? And afterwards, whenever you call this, whenever this particular statement got executed, it was supposed to call one more time, right? It did not call. What happened? Tell me in our next class. Okay, think about all these questions. Okay, all these questions are very important because that will kind of make all your doubts clear. Okay, so think about these things. Okay, and let me know. Yes, Tina, correct. Why it is not calling dummy? Why it is not calling dummy? Tina is telling it is not calling dummy constructor. Okay, let us try to execute. See here. It will call constructor for all the objects. Okay, it depends on what constructors are, depends on what constants we have defined. Okay, here it will, for all these things, it will call this particular constructor where you are passing your integer value. For these two things, it will call your default constructor. Okay, so but tell me, when we accessed this one for second time, right, for this particular statement, it should have got executed one more time, right? Why it did not get executed? Its constructors were not called one more time. Tell me what is the reason in the evening session. Okay, in the evening session, let me know what is the reason for that. Okay, so, but think about it. Take it as a kind of like interesting question. Okay, and then think about it and answer. Try to find out the answer why it is called only once. Okay, we all just by thinking or just by recollecting whatever we discussed today, you can conclude or you can come to an answer. But think about it and let me know. Okay, and then what are we doing here? We are trying to print the values here. Okay, let us not print the constructors part. Okay, so we know that the constructors are called as soon as we try to access one of the constant. But if you try to access this constant outside just like this, right, you have to create a variable and assign that value to assign that constant to a variable. Okay, that is when your constructors will get called. Okay, so here we are using values which will return an array of all the constants, which you can print it using your for loop. Okay, and then as with any other Java objects, you can call methods on your enumeration types. Okay, so whatever the value or constant that you have assigned to months with value variable MWV, that value will be printed here. Okay, or the month number, the associated with that month number will be printed here. Okay, let us not worry about this. Just trying few things. Okay, compare to let the comparative be there. Okay, so here we will discuss about comparative as well. So here we are displaying the number. Let us display okay, we are displaying the ordinal. So remember, for remember we have assigned 1 to 12 from Jan to December. Okay, that is our month number. Okay, that is our month number, but ordinal will be 0 to 11. Okay, these two will not have any values associated because sorry, those will have a value 1. Month number for dummy months will be, okay, let us make it 0, -1. Okay, let us make it -1. Okay, let us run this program. Okay, so the constructor is called all the objects are ready to use now. Okay, that is all your constants are ready to use now. Okay, so when we try to print it using after calling your get values or month with values dot values, it returned your array. Okay, that is what I am trying to print here. Month number and ordinal. Okay, month is January and month number is 1, which we have passed in our constructor. Okay, in our constructor. Okay, and month's ordinal is 0. That is Jan's position is 0. It is similar to your array indexes. Okay, Jan's position is 0. That is ordinal is 0, but the month number we have assigned is 1. Okay, so till December, month number is 12 and ordinal is 11. It starts from here 0, 1 position number 0, 1 till 12. Okay, so notice interesting thing, 13 and 12 and 13 or 13 and 14 in our thing, but 0 to 11, this is 12 and this is 13. That is what it shows. Okay, ordinal. Month is dummy month. Month number is 1 because -1 because we have assigned it in default constructor. Months already the ordinal is 12 and 13. Okay, then what are we doing? We are trying to print the ordinal of MWV, that is 1 because we have assigned which value did we assign? We have assigned Jan, right? Yeah, Jan is February. We have assigned February here, MBW, but we are printing 1. Ordinal should be 0. Why is it printing there? Okay, month number is 1, but ordinal of MVW is 0. Okay, both objects. We are comparing two objects. This is February and this is January. Objects are same. So when you try to use this one, it will try to compare both months are same. Give me a second. Both months are same. When we try to compare with the same object, it is returning in 0. That's why it is showing this one. But this one did not print because it is false. MEW and MEW1 are not same objects, because MEW1 is 1, that is February, and this one is January. Okay, they are not equal. That is why it did not print. Only this one printed, because we are trying to compare the same variable with another same variable using compare to. So how does compare to function works? It compares two objects. Okay, it compares. Sorry. Let me take this one only. Okay, so this is what we explained just now. Whenever you try to invoke one particular constant, right, that is when your constructors will be called. Okay, and then compare to function. So you are trying to compare two variables of same type. Okay, enumeration types. Two variables of enumeration type, that is MWV and MWV1. Okay, assume that you are comparing both of them. This is February, this is January. Okay, so it tries to compare this one with this one. Okay, if the result is negative, then this one is Jan is less than February. Okay, if the result is 0, then Jan is equal to some whatever the object that you are comparing. So in my case, I compared MWV with MWV. Okay, that is why it resulted in 0, and we were able to see the both objects are same. Okay, if it is 0, both objects are same. Both objects are same. If it is positive value, if it is positive, then Jan is greater than Feb. That is greater than is your dictionary meaning. Okay, that means Jan comes before February, like that. Okay. Yeah, sure. Yeah, Pawan is asking one question. I'm replying to him. Yeah, sure, Pawan. Yeah, let us see whether we can do it today. Otherwise, we will try to do it tomorrow after the class. Okay. He has some questions and he wanted some clarifications. I will try to have not sure. Okay, this is the question he is asking. Okay, he is a bit confused with Pawan is a bit confused with all these terminologies. Okay, that is your class, abstract class, interfaces, all those things. Okay, so he wants to kind of like explain those things. If anyone is interested, we will have a separate session. Maybe it may not be possible today because I cannot prepare for all those things on the fly itself. So probably, Pawan, we can have it tomorrow after the class. Okay, tomorrow we can after the class, after first session, we can have a class. Okay, is that good? Okay. Yeah, Hugh. I think compared to returns 1, 0, minus 1. Okay, yeah. Do you have any idea? Hugh is telling compared to returns 1, 0, minus 1. Okay, okay. Do you have any idea, Hugh, how it is calculated? So why do you say it is 1? Why do you say it is 1, 0, and minus 1? 1 minute. Let me unmute. Yep. Yeah, Hugh. Yeah, go ahead.
Yeah, I think one of the values represent if it's equal. I think if it's equal is positive, or if it's equal is 0. I can't remember which one. I think the other represent if it's not equal. I can't remember the third one. What the third one represent? The one represent if equal, one the other represent if it's not equal. I can't remember the third one.
Okay. Fine. Here. That is fine. Yeah, we'll be comparing with the positive, negative values only, and then it is like whatever the basic logic behind this compare to is you will compare one value, whatever the value that you have with your this one. What is that? The two objects are there, right? Object 1 or constant 1 dot compare to object 2. Don't get confused with the object means the class object. It is enumeration objects. Okay, I'm talking about enumeration objects. The same logic holds good for your objects, normal Java objects also. So what happens is, like, it will check whether object 1 comes first before, say for example, let us assume the ordinals itself. Okay, let us assume the ordinals itself. So say for example, your Jan's ordinal is 0, okay, and Feb's ordinal is 1, okay. How does it happen is, just assume this is the way it, okay, let us take another example. Okay, so let this example be here, okay. So when you try to invoke Jan dot compare to of Feb, okay, these are all constants. Don't just take, I'm a bit lazy to write all these things. So that's why I'm taking J and F, okay. So compare to means, say for example, if the logic is written by taking the ordinals, okay, how it happens is, it is always the ordinal of J minus F, that is invoking object and the parameter object, okay, that is 0 minus 1. The result is minus 1. Okay, that means J comes first and then F comes. Okay, J comes before F February. Okay, so if you are comparing J with J, ordinal of 0 minus 0 is 0. Okay, so both are equal. Okay, and now what is happening? Like, if it is positive, what happens? In that case, F minus J. So in this case, what we can do is, like, we are trying to compare say J, sorry, F compared to J. In this case, what are we doing? Ordinal 1. Ordinal of February is 1. J is 0. Okay, this is 1. Positive means this comes after this. Okay, that is why, I mean, that is how the results are derived. That is why we compared the value here. Okay, let us try to do this way. I try to compare two things here. Okay, give me a second. Okay, so what did I do here? I try to compare the same object. Okay, let us try to compare okay, so after this, let us try to compare. Okay, so let us have one more example. Did you get it, Hugh? So why did we get 10 here?
Yes, I follow it. Compared
Correct.
to is basically comparing the position and
Correct, exactly.
of the two. Yeah, I got it.
Exactly. Yeah, it is not just 1, 0 and -1. It depends on the ordinal. Okay, so that is what the logic is written in that way only. Based on the ordinal, the logic is written in that way. So it just for our thing, we just compare with positive value, negative value, and then 0. That's it. Okay, 0 means it is always equal. Both are having the same ordinal, and positive and negative. You can assume that one. Okay. Okay. Yeah. Okay. So let us continue. I think if you have any questions, we can. I can take it up now. Otherwise, we will continue with boxing and auto boxing. That's not a big topic. We can cover it up quickly. Okay. Yeah, Pawan. We will have. I'll let you know. Okay. I will reply to your email, Pawan. Okay. I will reply to your email. After the class, I will reply to your email. Okay. Yeah. Now let's start with the type wrappers. Okay. What are these type wrappers? We know primitive types are simple types, right? Our integers, whatever it is, from byte till our double. Okay. Primitive types. And then we have char and boolean. Okay. But they are not objects. They are all primitive types. They are not objects. You cannot call a method on this particular byte variable or int I is equal to 0. Okay, you cannot call a method on I dot some method because methods are not defined for these primitive data types. Okay, so methods are not defined. So these are all just primitive, simple types. They don't have any instance variables associated with them. They don't have methods to call. They don't have constructors. All those things. They are simple types. Okay, objects will have all these things, but there are certain packages. Okay, say for example, you have one package called very important package java.util. Okay, this is java.util package. This is what we discuss. We will discuss about collections. We will discuss about collections. Collections are nothing but group of objects. Okay, collections are nothing but group of objects. So here we are talking only about objects. Okay, we will talk only about objects. There is no place for primitive data types at all. Okay, that is one particular example. Okay, simple example. We are talking only about objects. So there is no place for primitive types. You can't store primitive types. If you want to store, you have to create an array and then store those primitive types in that array, primitive data type array. Okay, what if you want to use those primitive types in collections? You need some way to convert the primitive types to collections, right? You need some way to convert primitive types to not collection, objects. Okay, that is what is achieved using type wrappers. Okay, that is what is achieved using what are called as type wrappers. They are nothing but they are classes that encapsulate primitive type into an object. Okay, they are nothing but classes that encapsulate or that boxes a primitive type into an object. This is boxing. Okay, from object to primitive type is nothing but your unboxing. Okay, boxing and unboxing. So what are the valid type wrappers we have? We have for each primitive data type. This is for byte. So these are all once a particular primitive value, that is integer I, is equal to 10, right? So when you convert this or this value to an object, okay, so object, you know, constructors will be there, methods will be there. If at all public instance variables, the public instance variables will also be there. Okay, that's what is mentioned here. So you integrate primitive types into Java's object hierarchy. Okay, Java's object hierarchy. So I will discuss about this in next slide. Okay. So what are the corresponding type wrappers for byte? We have byte. Note that this is capital, this is small. Okay, this is lowercase, this is uppercase. Okay, corresponding constructor is simple constructor. So we will discuss all these things, all these type wrappers in detail when we discuss about one particular package, which we will be discussing hopefully by Monday. We will start this particular package. Okay, by then I am planning to complete all the basic stuff. Okay, all these packages will be like very easy if you understand what are the things that we discussed so far. Okay, whatever the basics that we discussed so far, they are very, very important. That is why whatever the topics that we discussed so far, they are very, very important. Based on that only, all other things will follow. That is your packages, important packages, java.lang, java.util, and java.io. These are all, without these packages, you can't do anything. Okay, you can't do anything, you can't write anything in Java. You can write simple programs, that is a different thing. But with these things, they will give you a lot of power in writing applications. Okay, so in order to understand all these things, you should have sound knowledge of your basics. Okay, that is your what is a class, what is an interface, what is why you use abstract classes, what are enumerations, what are generics, what are threads and all. We will try to cover all these things. Okay, in this weekend classes, okay, all these things, whatever we discuss now. That is why I kind of like went bit slow, but after we go to packages, we will just pick our pace. Okay, we'll do it little faster. Okay, because we know all the basics, and then we can kind of like do all the things quickly. Okay, so this is our primitive data type. This is the type wrapper. So how do you create an object with a value of byte? Just pass that value to a byte constructor. Note that it is capital. Okay, this is uppercase, this is lowercase. And how do you get? You have assumed that you have a particular object, byte object. You have assume you have 10 value 10. So how do this is what is called as boxing. Okay, so here, excuse me. So here you are boxing it. Okay, here you are calling, this is a method, right? This is a method. Okay, you cannot call this method on a primitive type on this byte. Okay, byte b is equal to some 10. So you cannot call b dot byte value because this is not an object, right? So this is a method, so it has to be called on an object. Okay, say for example, we have like this. Okay, and then you create an object. You can pass 10 directly also. Okay, this is called your boxing. Okay, this is what is called as boxing. What are you trying to do? This value you are trying to objectize it. You might not find this word anywhere. I'm just telling it. We're trying to convert the primitive type into object. Objectizing, okay? That is what is called as boxing. So now you have byte object. Okay. So we know that the value is 10 here. Okay. So the value of the byte object is 10. The value that is contained in byte object is 10. So you want to get that value out of your object. That is when you use byte obj dot byte value. Okay. Byte obj dot byte value. So you will get that value 10. You can again assign it to byte x. This is a different variable. This is a different variable. So you have created this and processed it, and down the line you wanted to get the value back. You use this particular method, byte value. You got and assigned it to x. And assigned it to x. Okay. So this is your boxing. This is your unboxing. Okay. Yes. Okay, so okay, Pawan, I'll sorry, I forgot your question altogether. Yeah, I will answer to your question. Okay, so before this, let me complete this one, and I will answer to your question on ordinal. Okay, sorry, I forgot your answer. Yeah, Kavita is asking, byte obj is together. What is that? The byte obj together? What is that, Kavita?
I mean, that example you have explained, like I got confused somewhere
Okay,
because byte
okay.
was.
Okay, let me take an example. Okay, that will kind of like make things simpler. Okay, just by explaining it won't be sufficient. Okay, let me take an example. Type the first test. I don't know whether I have it. Okay, I don't have it. Okay, so what am I doing here? Byte b is equal to 10. Okay, and then I want to convert it into an object. What I will do? Byte is equal to byte of b. Okay, this is boxing. Okay, now I have byte object. Okay, I want to assign it to some other this one. Now I want, so assume this is gone. Okay, I want to get this is gone and I can't assign it here, be like this. Assume that I don't have this object anymore, or this variable anymore. Okay, so now what should I do? I should get it from this object. So what will I do? Byte dot, sorry, byte obj dot, come on, okay, byte value. Okay, now let us print the values. What did happen? We're printing 10, it printed byte object, it printed 10, X is also 10. Okay, so this one is called as unboxing. Okay, we are assume that you have an object. Okay, so putting the value, so we have B is equal to 10. Okay, you are putting, assume that this is a box. Okay, you are putting this value inside box, that is, this is your object. Okay, this is boxing, this part is boxing, putting the value in object is boxing. Okay, taking that value from box is called as unboxing. Yeah, you are correct one. Yeah, it is not assigning. Yeah, correct. What you told is your understanding is correct. Assigning is boxing and retrieving is unboxing. Unboxing. Yeah, you one way that is also correct only. Okay. So what are we trying? Assigning is we are converting. It is not just assigning. This is assigning. Okay. This is assignment. Okay. Here also you are assigning, but you are creating an object, byte object or reference variable, and creating an object of that value. This is a value, right? This is B contains 10, that is primitive type. B contains 10, this is primitive type, right? So you are converting this primitive type to an object. You are promoting this to an object, byte object. This is just an example. Similarly, you can have integer object, all this stuff, okay? So what am I telling is, you are converting primitive type to an object. That is what is called as boxing. It is not assigning actually. Okay, so you can do this way also. Okay, let us go to this part little later, just 5 minutes. Okay. Yeah, we will discuss about those things, Kavita. Give me a second, okay? Okay. So what are we trying to do? This is a primitive type, or even we can do like this. Okay. So what are we trying to do? This value we are trying to convert it into object. Okay, that is called as boxing. So here we are trying to get the value that is there in your object using byte value method. This is unboxing. Okay, from object, now this value is whatever the value that was there here, that value has become an object. Okay, we have put it in object box. Okay, this is your box. So I have this inside the object box. Please let me know if you are getting confused. Okay, I might be thinking like it, I am explaining it in a super simple way, but you might find it a bit confusing or a bit difficult. Okay, so let me know if you are getting confused, or if at all I am trying to confuse you, so that I can explain it in a better way. Okay, so this is 10. I have boxed it, that is I have converted it into yeah, thanks you. So I converted it into box. Converted it into an object. This is boxing. Okay. So taking out from box is called as unboxing. That is what is the term means. Okay. That is how we do like this. That is what is done with these things. Okay. Using constructor, you box it. Using the byte value method, you unbox it. That is the normal way, traditional way, or what is a legacy way of doing it. Legacy way of doing things. Okay. So earlier we used to do like this. Whenever you want to do, okay, whenever you want to convert, say for example, I am using some collection to store some values. Okay. Or if I want to say for example, I want obj, or we can do one more thing. Okay. It will take okay. But this object will correct. Okay. Now what I will do, I will assign some values. Okay. So here we can store. Assume that we want to this object array is created only to store numeric values. Okay. Only to store. Assume. Numeric values. So this is the only thing that were given to you. You are given an object. You are given an array of object, which is a superclass of all classes. Okay, and you are asked to store 3 values, numeric values inside this. That is the only option you have. No other option. How can you do it? How can you do it? Okay, so I want to store all integers. Okay, manually I'm doing it. So what am I trying to do here? So this can take only objects. Okay, so any Java class, the superclass of all Java classes is object. Okay, in this not only integers, not only whatever the Java objects you can create, you can put it inside your object class. Okay, that can refer. We know, right? Superclass can refer to one thing, right? Superclass reference variable can refer to any of its subclass objects. Okay, any of its subclass object, right? We know that part. So that is why it can store only objects, and you are asked to store numeric values, any numeric values, 3 numeric values. I cannot do like this. Say obj of 0 is equal to 10. We can do it now, but before JDK5, we were not able to do it. If at all we want to do it, we have to do it like this. Okay, we have to do it like this. We have to first convert the value into object and then store it in your reference or in your object array. Okay, that is how we had to do before JDK5. And if you want, if you want the values, so you have to, I don't want this particular method, I will not be using that. Okay, if you want values, what I have to do, 0, see the difficulties. Okay, see the difficulties. It's not a difficulty, but before JDK 5 it was not a difficulty because everyone was doing it. So this one is, okay, let us copy the whole thing here. So that is all. Let us try to, let us remove this part. Don't want it. Okay, let us try to run this. Okay, sorry. So here you are boxing it and storing it in our array, and then here you are getting the values using your int value similar to byte value. Okay, you are getting it, unboxing it. Okay, this is what we used to do whenever before JDK 5. Okay, this is a type wrappers were there, but we used to do all these things manually, like this int value, byte value, and somewhere we had to kind of like cast it properly, casting and all. Okay, here we are boxing it, boxing. Okay, here we are unboxing. Okay, so this is what is unboxing, this is what is boxing. Okay, whenever you are using constructor, you are boxing it because you are converting the primitive type into object. Okay, from object you are getting the primitive value. Okay, that is unboxing using int value, byte value, or short value, long value, like that. Okay, so that is what is we used to do. But now after JDK 5, they introduced something called as auto boxing and auto unboxing, and auto unboxing. Okay, they introduced. So these things we need not have to worry at all. Based on the context, the value will get converted automatically. The value will get converted automatically. Okay, for example, okay, but still we are getting this error. It is saying mismatch, type mismatch. This is of type object. Okay, this is of type object. So it returns object. That is why we are trying to convert it into integer. The object value we are trying to convert it into integer. Just typecast it to integer. That is enough. Okay, but assume that if you have integer I int object is equal to integer of 10. Okay, so now you want to assign it to int j is equal to int obj. Are you seeing what they are you seeing any difference between this statement and these statements? Are you seeing? Earlier we used to do int obj dot int value of, okay, int obj of int value of to assign this value. Okay, similarly, what we can do is, that is all. Or you can say, you can create one integer I obj is equal to 10. Okay, so here we are not kind of like, here we are not doing this one, here we are not doing this one, they are done automatically. They are done automatically. That is why they are called as auto boxing or unboxing. Auto boxing or auto unboxing. That is why they are called as auto boxing or auto unboxing. Okay. So now after JDK5, they introduced this auto boxing and auto unboxing. That is why these things are valid. Before that, if you try to do that, they used to give compile time errors. So it greatly simplified coding. Okay. So did you all understand what is auto boxing and auto unboxing? Did you all understand? Okay, thanks you. Okay, anyone, if anyone has any doubts or questions or anyone needs any clarification, please let me know. I think that is what I wanted to cover for this session. So okay, so these things you understand, right? Each one has its own byte value, short value, int value, long value, float value, double value, char value, and boolean value corresponding constructor where you can pass directly or a variable or directly a value as I showed you, and then so in after JDK 1.5 they introduced auto boxing and unboxing. That is what is conversion of primitive type to boxing is conversion of primitive type to your object, that is encapsulation, and then from object to primitive value, that is unboxing. Okay, so that is what is unboxing and this thing. Okay, so these are some advantages, but this is a very I mean kind of like we will see what are these generics. Okay, so when we try to kind of like do generics, if you want to create an object which can hold only numeric values, that time we used to have a lot of difficulties. Okay, so this simplifies the generics part as well. Okay, that is it. So not only that one, you can not only assigning during your assignment and other things, this auto boxing and unboxing simplifies things. Okay, in an expression also you can use these things, auto boxing and unboxing. Say for example you have int x is equal to some value 10 plus int obj. Whenever I say obj, that means it is an object. Okay, and then you have some other int obj 2. Okay, so assume that you have 10, this has around 15, this is around 20. Okay, so the value will be 10, 20, 45. Okay, int x. Okay, so what exactly happens here? This object is converted into 15 and this is converted into 20. We are not doing it like int value of obj2, obj2 dot int value, or obj1 dot int value. We are not doing it manually. This is done automatically for us. Okay, and then finally 10 plus 15 plus 20 is calculated and assigned it to int x. Okay, assume that you have integer x is equal to same expression. Okay, so this plus 15 plus 20. So they are unboxed. Initially they are unboxed, they are calculated, that is 45, and then they are boxed and assigned it to x. Okay, this is boxing. They'll be stripped of their values. We will get the primitive value of each object. This is already primitive, and then the calculation is done, and then they are converted into object and assigned it to this particular value, that integer. Okay, that is what is the great advantage of introducing auto boxing and unboxing. Not only that, generics, we will see what are generics, all those things during this weekend, and we'll try to understand. So these are all very important and interesting topics: generics and annotations and threads. Okay, these are all very, very important: threads, annotations, and generics. Okay, now that we are familiar with the enumeration, so till now what are we discussed and what are we going to discuss with the generics, annotations, and threads, right? All from your basics of Java. Okay, so whatever you are going to do in your future with the Java, okay, whatever you are going to assume that you are going to start a career in Java itself, okay, all those things depends on your understanding of till whatever we cover here. So threading, annotations, and generics, and then whatever we discussed in our previous classes. Okay, so the better you understand all these concepts, the easier or quicker you can grasp other things that we discuss after our threading, annotations, and generics, right? So that is why I always kind of like take time to explain all these things. Even the minute things I will try to explain it, because when we start talking about Java packages, right, that is your starting point of your actual coding, Java coding. Okay, so if you understand all these concepts till threading, threads generally we will not use it so often. Okay, so only in product-based companies, and if at all anyone is developing anything very, say for example, someone there are a lot of frameworks. Okay, so you are developing some cache mechanism, all those things, right? That is when you have to consider all those things. Okay, normally you will not get into threads so much. So till threading, so what are the topics that we discussed? Classes, methods, interfaces, packages, abstract classes, all those things, right? Each and every topic is very, very important. Okay, so before starting packages, I just want to make sure that you revisit all these things. Okay, so once you understand all these things very well, all other things will become very easy. All other things will become very easy for you to grasp. So when all those things becomes very easy to grasp, you can learn quickly. Okay, you can learn quickly. That is the whole idea behind teaching all these things, or taking all these things a bit longer, okay, while completing these things. So even if I am kind of like telling some things again and again, that has that will, you'll see the result when we go to advanced topics. Not only advanced topics like advanced Java, also Java packages. So I will ask all of you to utilize this particular weekend and revise, learn whatever we have learned till now, and whatever we are going to learn in another couple of days. Revise it, or revise everything. Okay, revise everything, and understand it better. Okay, understanding is very, very important. Okay, digest whatever we have learned till now. That will give you a basic foundation on which you can do whatever you want to do. Okay, basic foundation for your Java career. That is what I would say. Okay, so whatever we are discussing now till threads, right? So if you are planning for a career in Java, okay, you should know all these basics till threads. Okay, very well. Okay, very, very well. You should know very well. And other concepts like inheritance, encapsulation, polymorphism. Okay, all these things if you know, and Java, basic Java packages, all your advanced Java, your frameworks, whatever is framework you want to learn, all those things will become very simple. Very simple. It is just knowing some classes and knowing concepts of how a particular framework works, or how a particular advanced Java concept works. That's it. Okay, that is why I always emphasize on core Java part. Okay, so with that I would like to take up any questions if you have. Otherwise, we will stop this session. Okay. Please let me know if you have any questions. Otherwise, we'll end up this session. Anyone has any question? Okay. Okay, Pawan. Yeah, Pawan, go ahead.
Yeah, I mean, you said you'll talk about the cardinal and the value of, right?
Yeah, correct. Yeah. Let me, thanks for reminding me. Okay. So, okay. Thanks for reminding. Okay. So, let me do this way. Okay. Okay. So, these are your constants, enumeration constants. Okay. So, these are your enumeration constants. Okay. Assume that you are so from you are coming from top to bottom. It can be from left to right also. Okay, like it was earlier. Okay. So assume that I have done it this way. Let's go from top to bottom. Okay. So the position, it starts from 0. Okay. So hope you understand the array indexes, right? Array indexes.
Yeah, right.
Array indexes, right?
Yeah.
So similar to that one, these are positions, right? From left to right or top to bottom. Okay. So this is your 0th position.
Okay.
This is your first position. This is your second. So this will be your 11th. Okay. So this is your position. Okay. That will be assigned by Java to your constants, enumeration constants. We will not bother about that. Okay. That will be assigned by Java. We will not assign manually. Okay. To say it in simpler way, we will not bother about that at all. Okay. That is Java's headache. Okay. So whenever you define something, not only the months, okay, say for example, I have one another enum, students, okay, sorry, so I have Pavan, okay, I have Kavita, okay, I have I have Hari, okay, there are so many other people, okay, Tina, okay, I just mentioned whichever came on top of my head, okay. So these are all your this one, what is that, your constants, okay. Students is an enumeration type, these are all your constants, okay. So position of Pavan is 0, position of Kavita is 1, Hugh 2, this one Hari 3, Tina 4. That is how it is assigned, the way it is from left to right or top to bottom, in whichever way you assign it, okay. It is just a position that is assigned by Java, okay. We will not bother about that, okay. Did you get it?
Yeah.
Okay. So these are the positions that are assigned by Java to all these enumeration constants, okay. So there is some specific reason for assigning these values, okay. So we will see that one. Yeah, while using compare to method, right? Compare to method, we used this one also. What is that? Ordinals also. Not only the type of enumeration. So anyway, we will be using both the invoking object or invoking constant and the parameter, right? Both should be of same type. Okay.
Okay.
So compare to method uses this ordinal. I showed you an example, right? This ordinal is written on which comes first and which comes last for sorting, right? For sorting, which that is used, right? So in order to check the ordinal or the position of a particular enumeration constant, we have one method called ordinal. Okay, we have one method called ordinal. Okay, say for example, if I want to check the ordinal of August, okay, so I will do like this: month, that is enumeration type, dot August dot ordinal. Okay, if I call this and try to print it, it will give 7. This is what this method will return. Okay, so let us see whether we have an example of that one. Let me know if you still have confusion, Pavan. Don't hesitate to ask. That is what I always tell, whether it is my whoever it is, my colleagues or whoever it is. Okay, it is like you are asking to get your doubts clarified, or you need some clarification on some concept. That's it. Okay. So let me know if you still have any this one. What is that? If you need any clarification.
Yeah,
okay.
sure.
So let us say what is the ordinal of this variable. Okay, how do you decide what is the variable, what is the value that is there inside this? Okay, we have assigned January. Okay, we have assigned January to that variable. Okay, hope I haven't assigned anything else in between. So okay, let me do one thing. Instead of confusing you, let me take only that part. Okay, let us execute this. Okay, so value of MWV is January because we have assigned this value to it.
Okay.
Okay, sorry, where is that? Okay, let us concentrate on this part. Okay. So this is the value that this is a constant that we assigned to this variable MWV. Okay, that is months with values. Okay, this is the value. January is the value that we have assigned it. Now the constant. That is assigned to MWV. Okay, if you want to print this whole thing, you can do that also. Just you have to override one method. Okay, override one method. So you figure out which method to override. Figure out which method to override. We can, if you want, we can do this way also. But default printing is this one. Okay, that is why we are getting the value as January. And then we did this one. Okay, so to clarify a little more, I will add one more one. Okay, one more line. Yes. Okay, dot value of what I will do, I will pass a string. So whatever the string that you pass here, that should match this. Okay, but remember this is, but remember this is a string. Okay, okay, but this one is type of this January is string. Okay, type of this January is okay. So if you want the value of January, this value, you have to pass the string that is equivalent to this one. Got it? Do you still have any doubts? To value
No,
of, right? Yeah. To value of, you are passing the string, which should match this one, this value, or this constant. You can say this constant. So if this has this value or this constant, it will return that value.
Okay. Okay.
So this will be matched, this string will be matched with this constant. Okay. So if that exists, you'll get that value. This is the constant, you'll get that value. This is the value.
Okay.
Okay. So when you try to run this program, you'll get the same value.
Okay.
Okay. January. Let us try some dummy value. Got it? Okay. So what does it say? Can you see my screen? Returns the enum constant of the specified enum type with a specified name. You're passing the name. Okay, here they have changed it. Here we are passing two things. One is your enum type and then the name. Okay, this specified name should match the enum constant. Name of the, I mean, like this constant that you have defined in your enumeration type. Okay, hope it is clear. If you have doubt, and let me know. Otherwise, okay. So otherwise, if you specify something else, it definitely should. They would have mentioned the exception here. Okay. Yeah, that's what is all about value of method. Okay.
Okay.
Okay, Pawan. Okay, I'll let you know about the other schedule. Okay.
Okay, sure.
If anybody wants to join, they will. I mean, we can send it.
Yeah, sure.
Okay, Pawan. Okay. Okay. Anyone has any other questions? Okay. Yeah. Thanks, everyone. Thanks a lot. Yeah. Have a great afternoon. Bye. Take care.